All right, let's go over the cumulative Unit 1 and 2 review for AP Statistics. Now, this review itself actually contains quite a bit more heavily on Unit 1 because we haven't seen that in a while. So you really do need to go back and look at the problems that we did right before this, which is the warm up and extra practice for Unit 2B, okay? Because that's got the more in-depth enrichment problems for this categorical and quantitative data, all right? So like the box plots and the mean, median, and mode and all those kinds of things. So make sure you have gone back and done that, looked back over that previous assignment as well. Okay, here we go on this one. Which one of these cannot be justified? I've got notes there. Keep in mind, you cannot tell how many pieces of data are in these sets. All right, so you can't compare the amount of data in those. Data set 1 and data set 2 have the same. Oh, which one of these cannot be justified? So which one is not true? Okay, here, take a look at these percentages. Notice that these are in percents, okay, and that these percentages add up to more than 100%. Therefore, I know that I can't have it in a pie chart because that must mean I've got some overlap. Okay, so I've got some people telling me that their dogs ride in more than one location in the car. All right, so then which one of these statements is false? And I state why the other ones are true, but this one, E, this is not true. E is not true because they could not be a pie chart because there's overlap. Now, I do want to point out why D is true. It says that it exaggerates the differences between the dog's riders in the lap versus passenger's lap, the driver's lap versus passenger's lap. So if you take a look at this, that's 20%. Well, that does not look like just about half of this. Okay, driver's lap versus passenger's lap. So almost half, but it doesn't look like half. And that's because over here on the y-axis, we're not starting at 0 like we should be. So that height is not as tall as it should look. Okay, and so it's looks like a fourth as much instead of about half as much. All right, next. Here we've got this IQ. So you had to actually do the 5-number summary and find out what your fences are and all that kind of stuff. The fence ended up being at 13. So that made 14 only an upper outlier. The lower fence was down low. Here, the variance between these measures, okay? So keep in mind that the variance is the standard deviation squared. Variance is that standard deviation squared. Which of the following are true? I actually kind of struggled with some of these, and I think I even looked up this third statement. But anyway, so we know 1 and 2, I was fine with those being true. I went ahead and I double checked this thing. Sample surveys are observational studies, not experiments. Yes, because with a survey, we are just collecting data from subjects with an already existing condition. My initial thought was, oh, I could do an experiment and then collect data from them. But so I looked that up. Okay. And when I looked it up, it said that surveys are taken from generally from randomly selected subjects from the population. They are not forcing anything on you, you're just collecting data. So that was then what made that one true. All right, number 6. The first was an experiment without a control group because you just had the bodybuilders do this and that. You didn't have anybody do nothing or an already existing thing that we knew of. Okay. All right. Next, true, false, false. All right. So this would be true. Careful use of control groups experiments can often indicate cause and effect. Okay. That is true. Unless based on careful use of control groups, so this might ought to be false. In hindsight, it says, based on careful use of control groups, experiments can often indicate cause and effect. So I'm almost thinking maybe I should go with false on this one as well. So I won't put anything on the test that's questionable. Okay, so don't worry about that. I kind of think that one could be false because, what is it that makes us say an experiment we can claim cause and effect? We randomly assign to the treatment group so we can claim the cause and effect. It's that random assignment that allows us to do cause and effect, not careful use of control groups. So in hindsight, I'm thinking I don't like that one. I think it's false. So I'm going to say 1, 2, and 3 are false. Okay. All right. Next, Jerry Springer's special show. We had 10,000 viewers who responded. It was definitely voluntary response sample. Here, this is interesting, talking about while this method results in a simple random sample, and that answer is no. With a simple random sample, every possible combination of 14 players would be possible. Okay, you simple random sample, putting them all in a big bag, shake well. So I could have gotten 12 players from one team and 2 from another. Okay, simple random sample, all mixtures of 14 is possible. But that's not what's happening here because we're going to take 2 from every team. So that's kind of controlling stuff. So I can't possibly get 12 from one team or even 6 from one team. All right, so that is why that is C. Here is another one. I just didn't, after I put these on your review and everything, I don't know about this one. I don't know if it's considered less costly. Um, I don't know if we can say that. If we can say that's true, then you can say D. So again, I didn't know about statement 1, but definitely 2 and 3 are true. So it's either D or E. Sorry on that one. Okay, next. This one says in designing an experiment, blocking, let's see, what is it saying? Blocking is used to reduce variation. Blocking reduces variation. You randomize to reduce bias. When you need to spread unknown traits evenly, randomize to reduce bias. But blocking reduces variation. What do you do? Make homogeneous groups. You group them together so it reduces the variation. Okay. Here, all of these 3 did not have a control group, and so I actually liked all of these statements. So all of the statements B through E are true. Here, you make an experiment. What do you do? Control, randomize, repeat. Okay, so now, 1 and true or 2. Using a single treatment to gain knowledge about the response. So I'm like, I don't really understand exactly what they're saying. We can't just say, okay, everybody, you do 5 grams of something or other. Okay. Um, we can also do more than a single treatment. We can do multiple treatments. So I think that is just that. I don't think it's implying we just do one different treatment per subject. So I put 1 and 2 are true, and I didn't like 3. It was too strangely written. Okie dokie. Here on this one, which of the following statements is correct? So this doesn't imply about all patients. Okay, so you certainly cannot say results are not necessarily typical for every subject. Okay, so the subjects, it's an average what we get when we do our sampling, so it's not stating what every single subject is going to lose weight or do whatever it says. Okay, here is our cumulative. These are cumulative percents here. So I can go through, and here I answered the question. The 4 and the 8 ounces. So what percent was between those ones? And that was the 40% of subjects. Here, Okay. You have got to know very securely that transformations, means are affected by everything but standard deviation. Measures of spread are not affected by shift. Measures of spread are not affected by adding and subtracting. So that ended up being 0.54. You must know that. Measures of position, where things are located, mean, median, even Q1 and Q3, where those are located, are affected by moving, addition, and subtracting. But the spread is not affected by addition and subtraction. Okie dokie, here we have all of this. This was just stating the variables properly. Next. Okay, here's another ogive. So what was the median? It was there at about 2.4-ish. Okay, what is the IQR? So I had to find out what that Q3 was and that Q1, and then I subtracted. Okay, next, here is who can you generalize to? So we took a random sample of 50 teachers from the mathematics teachers attending the conference. Oh, I don't like this answer here. It's not all teachers who attended the conference. Nope. It's the mathematics teachers who attended the conference. Okay. So that mathematics, we only sampled mathematics teachers. So we're going to be able to generalize to mathematics teachers only. Okay. All right. Next. Here we have again another experimental design. Okay, make sure you know what conclusions you can draw from different things. So here we go. So this problem is seeing if you know the conclusions you have the right to draw from an experiment versus observational study. In an experiment, when you have random assignment, you can claim cause and effect. But you are generally limited on who you can generalize to because those, a lot of times, not always, but they are volunteers. Or you can generalize to subjects similar to those volunteers because they might have a particular quality. They're more health conscious or they're more desperate or whatever. Okay? Now, if it was randomly selected tomato plants, then yes, you could generalize to all tomato plants. Okay? But sometimes experiments are limited in who we can generalize to, especially with human subjects. Now, observational studies, remember, observational studies do not have random assignment to a treatment. So you cannot claim cause and effect. There could be some other lurking variable that's making it look like there's a link when it may not be the cause. Okay? But with observational studies, a lot of times you have random selection. And then if you have random selection, then you can generalize. All right, so with this problem, it was about saying that we can conclude cause and effect, okay, and we can only generalize to adults similar to those in the study. All right, you have to be proficient. I mean, multiple times I know on this test, you have to be able to look at a histogram or even look at a table, a frequency table, and find where the median Q1 and Q3 are located. You have to. So get that straight. Here, of course, with 100 pieces of data, we know that our Q1 is going to be between the 25th and the 26th piece of data. So here are the first 24 pieces. So the 25th and 26th are in this bar. So I know that my Q1 has a value of 66. And then I go 25 down from the top, and I know my Q1 is going to be a value of 71. So now that I have those, I can subtract, and I can see that my IQR is 5. You have to be able to do that, okay? All right, next, which one has the smallest standard deviation? And that would be the one most closely clustered to the center. The one most close, because make sure we know standard deviation is the average distance from the mean. So the definition is the average distance from the mean. Okay? So, if you are asked, what's the interpretation of this standard deviation? Look for the answer that's describing the average distance that all the pieces of data, average distance that all of the individual pieces of data are from the mean. Okay, very important there. All right, next. Okay, here we go. We've got this one. The mean is greater than the median. I actually computed the fence with this information, and I found that I had 2 upper outliers. Okay, here, remember that you keep in mind that you don't know how many of brand X, Y, or Z there are. So you can compare percentages like within brand Y. So I could compare the black and the spotted area for brand Y, but I can't compare the number values, how many pieces of data there are in brand Z black section and brand Y black section, because they could have different totals that those percentages are out of. So the answer here, I didn't put what the answer was. So I guess that it's B. Okay, so answer choice B, yes, we can, because we are comparing out of the same bag of Y, brand Y. Okay, free responses. Here we go. Remember why we block. Okay, and that's what this problem was getting at. We block, and you need to know this, we block because there is some kind of trait that is happening that will affect what we are measuring. And so we were measuring arsenic, and granite and burned forests were known to have an impact on the amount of arsenic. So we wanted to control that trait because of that. So the question is, under what conditions will you decide to block? So basically this question is saying, why do you decide to block? So I wrote, so basically this question is asking why you would choose to block. I wrote this: block by location of the wells, so like by the granite ledge or by the burned forest, okay? Because those natural occurrences, the granite ledge and the burned forest, have an impact on how much arsenic is in those areas. Okay, and that comes straight from our block by this because. Okay, so that answers in the grading guidelines, the water well arsenic concentration. Okay, wait, that answers this. The average water well arsenic concentration will vary from block to block. So that's what that answers, is that statement there. I'm going to block by those things because the arsenic is similar. It affects how much there is. And so look, then I said this would make all the land sections in a block have the same arsenic concentrations because of the natural surroundings. So all of the land masses near the granite ledge, those are then all having the same exposure to the granite ledge. So now they're like on the same baseline. They have all the same granite ledge arsenic in them. And now we see what the filter can do. Okay. And they all have the same kind of baseline arsenic in them. And same thing, say the ones by the burned forest have the same baseline arsenic in them. Okay. So they have the same arsenic concentrations. Therefore, any differences that we would find are then due to the filter. And so that's answering this question. The water arsenic concentrations are similar for all the wells in those blocks. Okay. The next question then asks, how would you then identify what goes in the blocks? Well, I would make 1, 2, 3, and 4 be one block because those are the ones all closest to the granite ledge, and 5, 6, 7, and 8 be then the other block because those are all in the burned forest. Okay. Now, some people, if you described it to make matched pairs, then you could do like a 1 and 5. Well, I still don't like no, matched pairs, no. Okay, here we go. Next, describe how you will assign the filters to create randomized block design. So look, I'm going to put all the numbers 1, 2, 3, 4 in a big bag, shake well to randomize. I'll pull out 2 of the numbers for the new filter and 2 of the numbers for the old filter. Done. And then I described what I was doing for the other block. So that's how I get my correct. Within each block, each type of filter is assigned to half of the wells. Okay? And I'm of course using I show exactly how I could complete this process. So I'm describing the big bag thing, and I indicate the 2 types of filters are randomly assigned to those wells. Okay? All right, next, here's another AP question. Here, make sure that you know how to tell the shape of the distribution from this. So like from here, I can turn my paper sideways and I can see that I have this skewed to the right. Okay, now keep in mind that if you had data over here on this side skewed to the right, would look like that. Okay, because you still have to go from least to greatest. Skewed to the right would look like that on the other side. Okay, hold on. Yes. Okay, skewed to the right would look like that on the other side. Okay. All right. So anyway, again, on this one, you had to find if there were outliers. So look, I actually computed information here. Okay. Did all the specifics, and I found that 8-1 is an outlier. Now, notice that 1-2 means $120. So this 8-1 means $810. Okay, so keep the context in mind. So describe the procedure for identifying potential outliers. Because of the skew, I'm going to use IQR rule. First, I got the median and the quartiles, and they are these numbers. Then I found the IQR by doing Q3 minus Q1. Then I did 1.5 times the IQR, and I added it to Q3, and I subtracted it from Q1. And then any data above the upper fence is an upper outlier, and any data below the lower fence is an outlier. Therefore, 810 is the outlier. Describe the distribution. That's the shape and the outlier in the center and spread, and make sure you're including context and specific numbers in there. All right, next here we had comparing distributions. This one is a toughie. Man, this one messed with my mind because it was times past 9 o'clock, and also they were time ranges. So I went ahead and I did all of that. I did all the data. Q1 was between this 15 and 30, which meant 9:15 and 9:30. And Q3 was between 10:30 and 10:45. Anyway, so I I ended up thinking that in this one over here, which was very much less varied, okay? So we ended up saying that Q1 was, I think it was like basically right on this thing. So I was like tired by that point. I just said, I'm just going to say it's, I should have said 11:15. Oh, it's 11:15. Yeah. So I said Q1 was, I just said 10:15. And then I said Q3, it ended up being pretty much right on the baseline. So I said Q3, you're pretty much going to be at the top of that. So I'm going to say you're 10:45. So I got a little bit lazy on that. So there I had a range of fences on this side, and this one I had a pretty secure fence. Anyway, how many of the 60 sites had an exit time before 8:30? 3 of the families had an exit time before 8:30. There were families without children. None of the families with children exited before 8:30. How many of the 60 sites had an exit time 11 a.m. or later? And so I went ahead 8 total, but I differentiated, so 5 families without, 3 with. You didn't have to differentiate to get credit on that. Okay. All right. Next, compare the distributions. So this is where then you had to go into all that detail so that I could give specific centers, okay, and specific spreads. So there was skew, shape-wise, here I had skewed to the left for the ones without families, and this was somewhat symmetric for the ones that were with families. Okay, and they were definitely centered higher than these over here without families. The ones with families are with children are taking longer to get out of the campsite. Okay, so I'll just leave that there for you to look through. Notice in the grading guidelines, you had to compare the centers, the spreads, the shapes, and you had to include context. And now, I liked this one. Estimating a reasonable median exit time for all 60 of them. So what I noticed was that over here, this without young children, there were 40. Okay. And then with young children, there was 20. So 2/3 of the data was this information here on the left. Only 1/3 of the data was this information here on the right. So if you did some kind of something based off of that, you got credit. If you gave a specific time or range between 10:15 and 10:30, between 75 or 90, depending on if you just kept it, and you had to explain why you did that, then you got full credit. Now, what I did was this, a combination of the medians that properly weights the medians in a 2-to-1 ratio. So that's what I did here. I said 2/3 of the 10 to 10:30, and then that's 10:10. Upper estimate was, and then 1/3 of the 90-minute, or the seven, that one. And I did 2/3 of the 10 to 10:45, okay, and 1/3 of the whatever other time that was. See, 2/3 of the 10 to 10:15 and 1/3 of the 1:30 to 1:45. So I kind of included that 2/3 to 1/3 ratio and the ranges that those medians were in. Okay, so I think that was all. But you have got to make sure that you go back and you take a look at this review that we had the day before, okay? This warm up and practice, especially making sure that you can look at a set of data and you can identify from a set of data where the median is in a histogram, especially. You know, you should be able to look at a histogram such as this and find where the quartiles are and where the medians are located. Okay, make sure you can give those specific locations. I'm trying to see if any of those of this does this. Even looking at something like this, if this was, you could then take these numbers. Make sure you could find the median of these. If I lined all of these up in order from least to greatest, and there's 150, then I need to go to the between the 75th and 76th and find what the median starting salary is. Okay. So you need to be able to find those quartiles and medians from histograms and frequency charts. Okay? All right. Good luck to you. I hope that helped you with your Units 1 and 2 review.